All right, ladies and gentlemen, we are going to do our multiple choice review for semester 2 in a couple of different ways. There will be a multiple choice review that looks a lot like the exam itself, but we're also going to have a portion of this where we call it the Remember When We section here. I can thank Mrs. Abruzzo for setting some of these up, but what we're going to do is I'm going to have a page where I do a few examples, 2 or 3 with you to go through some stuff, and then there's going to be a practice on the back of each. So like on this first one we're going to look at function operations. We're going to go through a couple together, then if you flip over to the back there's going to be some practice that I'm going to have some keys for. I'm purposefully going to leave a few on the front blank though too, in case you have some questions you can come up and I can work through some of this with you. So I'm going to do one of the subtraction ones here, 1 through 4, and then I'm going to do one of the ones down below. Again, just a little bit of an overview for how we're working this. So up here at the top, let's find something that looks kind of interesting. Let's just start at number 1. Find f of x minus g of x. Okay, so f of x minus g of x. Now here, since it's subtraction, now if it was addition I wouldn't have much to think about. But since it's subtraction, I need to distribute that minus through to both of my terms after the minus. Again, the parentheses help me remember that. If I don't have them, I'm probably going to forget. And then when we write our answers, we always write them in standard form, which means we go from our largest degree, work our way down, and finally, if we ever have like terms, which we will at times, we're going to go ahead and put those together. Now sometimes, and I noticed this, so here I go already going against what I said and doing an extra. If we see one like number 3, we've got g of n minus f of n. Again, I do my distributing. You're like, how is this any different than the first one he did? Here's the difference. When I go to put it together this time, I do notice this time I have an n to the third. So that's what I start with. And then I have an n squared. And then I have an n term. And you're like, hey, there's no like terms. That's okay. Sometimes you're not going to have any. It's just something to watch out for. When we get a little lower here, and I'll do a couple of these too. We'll do 5 and 6. Okay. Composition. We're always doing what's in the parentheses first and the function outside second. So my first job is to do h of 5. In other words, take my h function, 2x, and replace the x with what's in the parentheses. Gets me an answer. When I go to do the second part with g, now I'm not using 5, I'm using my answer from number 1, which is 10. I plug that in for my x up here, and get my answer. And really the only caution I have to take as I'm doing these is kind of on this first one here. Because sometimes people forget the parentheses around their -2 here, and that's going to be important. The other thing people tend to do, unless they do it in the calculator, is oftentimes they'll multiply these and then square it, and that's not how this works. You're squaring the -2. Negative times negative would be a positive 4. Positive 4, we just said that, times -3 is -12. Minus 1 is -13. That's going to be the value I plug in for my function on the outside, for my g. And again, the negative's already there. Now I'm plugging in my x value. Okay? So this negative and this negative, 2 separate ones. And what happens when we minus a negative? Hopefully somebody said it becomes plus. And I get that one set. Okay? So again, there's a couple more practice on this side. There's some others on the other side too to kind of get you into the flow of things. On to the next page. Oh dear. Remember we could factor like ninjas. Hi-ya! Didn't even see my hands moving through there, did you? That's what I thought. Okay. Here, we're going to pair off our terms. We're going to look at them a pair at a time. So we're going to forget this guy's even here. Okay. 6 and 16. If you have to play with the calculator, you do here. But you'd find that 2 is going to be the largest one they have in common. It divides out. When I'm looking at my variable terms, we're going to take the smaller exponent. 2 times what gets me to 6. 2 plus what gets me to 3. A, or a to the first. 2 times what gets me to negative 16. And 2 and 2. And then we just flip it around. Now, if I do this right, I should get the same set of parentheses back. We'll see. What divides into both of those? Again, I can play with the calculator some, find out there's 3. No variable this time. This has a variable, this doesn't. So let's see what we get. 3 times what gets me to 9? 3. There's my A, because I didn't have one out here already. 3 times what gets me to negative 24? Woo! Same thing. So when I go to write my answer, it's just the stuff that's outside goes together and my common set of parentheses go together. And that's how all of these will set up. But again, the key is, are these the same? If they are, perfect. If they aren't, that's going to be a little bit different of a story we've got to watch out for. Okay? So as we continue to look at this, we go down a little further. I'm going to hit a couple of these on the bottom because there's some issues we could have here. So we're going to take a peek down here at number 6 and 8. Now at first look, you're like, that's just weird. What's going on here? K to the 4th? What the? Okay, we're going to treat this like it's k squared. You remember all those differences of squares that we keep having options with? Well, here's another one. So since we're not going to have a multiplication chart, since we're not going to have any other little helpful papers for us, what we're going to have to do here is we're going to have to trust the calculator. Now, in this case, I know the square root is 16. 4 times 4 is 16. If this was squared, we'd just write k here. But it's not. 1 plus 1 is 2. 2 plus 2 is 4. Okay, that's going to be my difference here. And 625, that's just a really big number. 625 is 25. So now it works just like a difference of squares would. 4k squared minus 25. 4k squared plus 25. But there's one more issue. You're like, oh man, this is still a difference of squares. There's no such thing as a sum of squares, so that one's done. We're going to leave it alone. This one, I can square 2 and k to get 2k squared. I can square 5 to get 25. And so now I take that 2k and that 5. And since it's a negative 25, we do some plus minus. But again, there's no such thing as a sum of squares. So there's a lot of breaking down to be done there. Okay, I've got to really stay on top of this. And so since this is kind of different, I want to look at number 8 as well, just to kind of get you on a roll. You're like, all right, so b to the 4th would be b squared. Then 256, maybe again, I don't know off the top of my head. We can fit, oops, probably got to do the square root first. 16. And so just like we did up above, treat it like a difference of squares. b squared, 16, 16, plus minus. You're like, it didn't happen again. With to the 4th, it will a lot of the time. Always look at the minus one and say, hey, can I square something to get each of those? And if the answer is yes, and it is, we make 2 sets of parentheses again. Put each of my squares, 1 plus, 1 minus, and we leave the sum alone. And we're set. Okay? Now, will every single difference of squares have to be broken down twice? the thing you've got to watch for is the fourth. Okay, if the fourth is there, there's a distinct possibility it may break down twice. But if it's just squared, it'll only break down once, just like they have been. So factor ninjas, back to that as well. Remember when we graphed growth and decay functions, okay? Growth or decay, look at the value that you're taking to the exponent, okay? If it's greater than 1, it's going to be growth. If it's less than 1, it's going to be decay, which lets me know kind of what my graph's going to look like, whether it's up to the right or down to the right. Shifts up in the exponent are my left-right shifts. Okay, so this one's left 2. This also would be left 2. But if it would have been minus 2, like it is down in number 3, then that would be right 2. At the end is my up-down. So in this case, we'd be down 2. Down 1. Okay, if it was plus, that's my up-down. Okay. Horizontal asymptote. Goes right along with my up or down shift. So if I have a horizontal asymptote here, that's at y equals negative 2, because I went down 2. Over here, my horizontal asymptote is going to be at y equals negative 1, because I went down 1. You're like, now wait, what's that mean again? Okay, so when I'm looking at these, that just means there's this dotted line that goes across, saying that's my do not cross line, okay? Graph, don't go past here, or else. Now, domain and range I will actually save until we have the picture, even though we could do it without. And then I'm also going to do that with end behavior. So, I'm going to assume a lot of you, even though you wouldn't have to, are going to go to a calculator on this. So, when we go ahead and get this put in, we're going to do these one at a time. Okay, we can kind of look at our picture. I saw how it went down there. So as I'm looking at my graph, if I pull up my chart, okay, again, we don't want to get into all the crazy fractionally numbers. We don't have to get that specific with things. So I'm just going to kind of work my way through here. Get some of these in. I mean, I guess technically I don't even need to quite put this many, but I like to be accurate. But here's what I wanted to make note of. As I keep scrolling up, notice I'm getting closer and closer to negative 2, my horizontal asymptote. But I'm never going to cross it. I also notice when I connect the dots, it looks like the picture I had at the start. So how is that going to connect me now with domain and range? Okay, whenever we're doing growth and decay, my domain is always the same. It's infinite. It goes forever left and forever stretches out to the right. My range is normally 0 to infinity, bottom to top, unless there's an up or a down shift. Well, here, my horizontal asymptote tells me where the bottom of my range is. But I'm still going to go up forever, and that's going to be true. And as we've spoken of a lot lately, my end behavior my x's for my end behavior are always negative and positive infinity. We've chatted about that quite often too. My f of x or my y goes along with my range. So these are going to be my two range values. So if I go back and I look at my picture, as x is going to negative infinity to the left, am I getting closer to y equals negative 2 or y equals infinity? Well, it doesn't look like it's going up forever to me right now. So negative 2. Whoa, come back. As I go to the right, up, 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 to infinity. So do you see where all the pieces come into play? They keep making connection after connection with these. And it's going to be the same thing on my next one. Now, let's do a little of our extra work before we even graph it. Domain, don't have to think much. I already know. Range, again, goes right with my horizontal asymptote. -1 to infinity. Now, my end behavior here, I may have to think a little bit. Because I know the x part, but the f of x, I may need to see the picture. It may depend. So let's get this one typed in and see what's going on here. Get my chart up. And I'm like, ooh, that's decimally. So, all right. So -2, 0. -3, 3. -4, 15. And then as I start to scroll down, what number am I getting close to? I see repeating a lot. -1, my horizontal asymptote. So here, we went down to the right, which is what we thought we would do. And so I look at my graph now, and I go, okay, as x goes to -infinity, as x goes to the left, y is going up, 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 up. As x goes to positive infinity, as x goes to the right. To the right, towards -1. Range f of x, domain x. Okay. So again, we've got some more for you to play with, practice with, and see how it's going. Remember again here when we solved applications of exponentials. Again, formula's there. All I'm doing is looking for words like decreases, grows, and then I'm kind of plugging them in. So, again, some of these I'm going to do. I'm not going to do all of them because a lot of them we've done a lot of. So, decreases, my model would be my base population, 1 minus my percentage, and this is typically going to be t. That's my model. But then when we're asked for a specific number, in this case the population, I'm just going to take that value. And now instead of putting t up there, I started in 2018. It's now 2028. So my t would be 10. And again, we normally don't talk in partial people, so rounding, and if you rounded to 112 or 113, I'm fine with that. I look a little further. I go to number 2. Okay, we're estimating beginning with 470 bacteria, growing, so we're plussing it. There's my equation. Now this one's a little different. How many minutes will pass before the bacteria reaches a population of 1,000? In other words, when does y become greater than 1,000? So now I don't have a choice this time. I got to go to y equals. And I'm going to type my equation in, which right now is off the screen. So let me get it on here for us. Okay, that's going to stay as a variable. And when I look at my chart, now I'm looking to see when's the first time I see y go above 1,000. And once I see it, 7. Okay, we talked before about how you can even do a range on this. You're like, well, actually the 1,000 happens somewhere in here. So if I wanted to put 6 to 7 minutes, that would be okay as well. But that's how those set up. Growth of a muscle car's value after its creation in 65 can be represented by the equation. What's the value of the car in 1965? What's the value of the car when t equals 0 in the base year? Well, if I went ahead and typed this in, I get 1,300 back. Is that a coincidence? No. If it's the original year, it's going to be the A value. Okay. The annual rate of growth is based on the decimal. Not the 1.03, just the 0.03. And we turn that back into a percentage by multiplying by 100. The last two on here, the hotel room, okay? And then number 5 with the salary comparisons. We've done so many of them. You've got about 6 different videos you can look back on them. So I am not going to touch upon those right now. But if you run into an issue, come see me. We can take a peek. And finally, our buddies. Multiplying, dividing, rational expressions, all that good stuff. I'm going to go to number 2. Because I notice a few things. I notice if I can factor something, I should. If I can't, I don't. If I see divide, it means I flip it. Ooh, what's that? You better know after what we did about 10 minutes ago. Difference of squares. 2 sets of parentheses. Some of you are like, dang, dude, you're going fast. At this point, you've got to know some of what I'm going on here with. Both have an x squared in common. Okay, so I look and I go, okay, what can I zap? The x minus 8s, the x plus 8s. So let's say I'm not sure at this point. So I just write everything that's left in the numerator and everything that's left in the denominator. And I look. Can I do something with this? But can I? Yes, they're not bonded. So 2 minus 1 is 1. So that will give us down to 1 up in the numerator. This guy will go bye-bye. Okay. He cannot cancel with him. Bonded. These are not the same. That's as far as I go. Okay. When we're adding or subtracting, again, got to keep an eye on, is it bonded or not? If they're not, they both need to be part of my LCD. And if I build a new LCD, I need to build new numerators. Check off what I already got, put in what I need. Check off what I've already got, put in what I need. So I look here, I got some distributing to do. Do not get rid of your denominator. This is not an equation. So 6x plus 2x plus 10. 8x plus 10 over x plus 5. Now, normally I wouldn't circle that because I'd look first, I'd say, hey, I can still take a 2 out of here. Now, if I see that, that's even better. Can't cancel those. 2 and x don't cancel. This is like the answer, if we're looking at those. And finally, last one to play with here, excluded values. We're just looking at denominators. If it's factorable, we may have to factor it. If it's not, we just set it equal to 0 and go about our business. So I could factor the first one I did. I set each of the parentheses equal to 0. And whatever I get from those are my excluded values. Ladies and gentlemen, you have practices on the other side. You have some additional ones on here I'm happy to work with you on. This video will be online along with the key for the practice sides on these. The multiple choice review is still coming, so keep studying so these finals go well.